NASA's MAVEN Mars Atmosphere and Volatile Evolution spacecraft, a remarkable piece of engineering and a pioneer in studying Mars' upper atmosphere, has been an essential asset to our understanding of the red planet. Launched in November 2013, MAVEN's mission was to explore the Martian atmosphere and its history, studying how the planet's atmosphere has evolved and lost volatile compounds over billions of years. This spacecraft was instrumental in unraveling the mysteries of Mars' climate and its ability to support liquid water in its distant past. For more than a decade, MAVEN continuously transmitted crucial data, helping scientists piece together a detailed picture of Mars' atmospheric conditions and its atmospheric escape processes. MAVEN's success in these studies had made it one of NASA's most dependable orbiters around the red planet. However, in a surprising twist of events, the spacecraft mysteriously went offline on December 6, 2025, causing a significant pause in the flow of vital data for Mars. MAVEN's unexpected silence sent ripples of concern throughout NASA and the scientific community, especially given how crucial the spacecraft was in conducting atmospheric and climate studies of Mars. The spacecraft had been designed to provide scientists with high-fidelity data that could give insights into Mars' past climate and atmospheric history. MAVEN's observations had already provided vital information about how Mars once had a thicker atmosphere capable of supporting liquid water on its surface and why it eventually lost much of its atmosphere to space. The spacecraft was expected to send telemetry data back to Earth on December 6th, as it had done countless times before. These telemetry signals are crucial for mission control to assess the spacecraft's health and status. However, on that fateful day, no telemetry signals were received, and MAVEN went silent, sparking concerns about the spacecraft's condition. NASA's Deep Space Network, a global system of massive radio antennas that serves as the backbone for interplanetary communications, failed to pick up any signal from MAVEN, despite its extensive tracking capabilities. This sudden loss of communication with MAVEN was highly unusual, as the spacecraft had always been reliable in sending signals back to Earth, even during challenging maneuvers or long periods of silence. The absence of signals raised questions about whether the spacecraft had suffered a mechanical failure, experienced an electrical issue, or encountered some other kind of malfunction that had disrupted its ability to communicate with Earth. The situation was especially worrying because of MAVEN's critical role in studying the Martian atmosphere, and the potential loss of its data would have significant ramifications for ongoing Mars research. Days later, on December 12th, NASA provided an update, shedding some light on what might have caused the communication breakdown. The agency stated that MAVEN appeared to be rotating in an unexpected manner when it emerged from behind Mars. This unexpected rotation suggested that there might have been a problem with the spacecraft's attitude control system, which is responsible for orienting the spacecraft and keeping it pointed in the correct direction for communications with Earth and other scientific observations. MAVEN's rotation could have caused its antennas to point in the wrong direction, preventing the spacecraft from transmitting signals back to NASA's Deep Space Network. This, in turn, would have resulted in the failure to receive telemetry data. Such a rotation anomaly could have been caused by various factors, such as issues with the spacecraft's reaction wheels, gyroscopes, or other systems responsible for maintaining its orientation in space. Despite the hopeful tone of the update, the situation did not improve as quickly as expected. On December 23rd, NASA issued another update, stating that the agency was still working to make contact with the spacecraft, but there was no sign of successful communication yet. The agency statement indicated that they were making efforts to create a timeline of possible events and identify the likely root cause of the issue. This effort was crucial because understanding what had caused the spacecraft to go offline would help engineers and scientists determine how to fix the problem and potentially re-establish contact with MAVEN. NASA was also analyzing tracking data fragments recovered from a December 6th radio science campaign in an attempt to understand what went wrong and to diagnose the situation. MAVEN's status remained unresolved as the weeks passed, and the situation became more dire. On January 5, 2026, Space News senior writer Jeff Faust reported that Louise Proctor, NASA's Planetary Science Division Director, had conceded that it was very unlikely the agency would be able to recover the MAVEN spacecraft. This admission from one of NASA's key leaders signified a sobering reality. While the initial hope was that MAVEN would simply be in a temporary communication blackout and that it could be re-established after a few days or weeks, Proctor's statement suggested that the spacecraft may have suffered permanent damage, or that a solution might be beyond the reach of current technology and efforts. The timing of this unfortunate incident is especially important, as Mars and Earth are currently in a period of solar conjunction. Solar conjunction occurs when Mars and Earth are on opposite sides of the Sun, causing a temporary disruption in communications between the two planets. This phenomenon, which lasts for several weeks, is a natural occurrence that has been anticipated since the beginning of the MAVEN mission. The Sun's interference with radio signals makes it difficult for NASA to communicate with spacecraft on Mars, and this is the primary reason why MAVEN's last communications took place before this period began. The solar conjunction will end on January 16, 2026, offering NASA a renewed window of opportunity to attempt to re-establish contact with MAVEN. However, by the time that happens, MAVEN's situation may have worsened, or it may be too late to make any meaningful repairs or adjustments to the spacecraft. Despite the grim outlook, hope is not entirely lost. NASA has continued to explore alternative methods of regaining contact with the spacecraft. In its last update, NASA revealed that the MAVEN team had attempted to use the MASTCAM instrument on the Curiosity rover to take a picture of MAVEN in orbit around Mars. This would have helped to visually confirm the spacecraft's condition and possibly detect any anomalies that could be affecting its operations. Unfortunately, the Curiosity rover's efforts were unsuccessful, and MAVEN could not be detected. However, the fact that NASA continues to make these efforts shows the agency's dedication to recovering MAVEN and learning as much as possible from the spacecraft before its potential loss. There is still a glimmer of hope for Mars communications, as there are 3 other spacecraft currently operating on Mars. These spacecraft, which include NASA's Mars Odyssey orbiter, the Mars Reconnaissance Orbiter (MRO), and the European Space Agency's Trace Gas Orbiter (TGO), are capable of relaying communications between Mars and Earth. These spacecraft can continue their work of relaying data from other Mars missions to Earth, including the Perseverance rover, the Curiosity rover, and various landers, ensuring that Mars exploration does not come to a complete halt. Additionally, NASA has recently revived plans to launch the Mars Telecommunications Orbiter (MTO), a next-generation communications relay spacecraft. This spacecraft, which was included in former President Donald Trump's Big Beautiful Bill Act, is designed to provide more robust and reliable communication capabilities for future Mars missions. Although the MTO's launch date remains unclear, it could provide an essential backup to the existing relay network and ensure the continued success of Mars exploration missions. While the outlook for MAVEN may appear bleak, it is important to note that NASA's exploration of Mars is far from over. The agency's work with Mars continues through multiple missions, and MAVEN's legacy will endure regardless of the outcome. MAVEN has already provided a wealth of scientific knowledge that will contribute to our understanding of Mars for years to come, and its data will be analyzed for many years into the future. The spacecraft's contributions have been immeasurable, and it is a testament to the incredible work done by the NASA team over the past decade. As for MAVEN itself, it remains to be seen whether the spacecraft can be re-established or if it will remain silent for the remainder of its mission. However, as the days pass, the window for recovery grows smaller, and the hope for MAVEN's return diminishes. In the end, MAVEN's disappearance serves as a stark reminder of the challenges and risks involved in space exploration. While space missions have brought us closer to unraveling the mysteries of distant worlds, they also remind us of the fragility of technology in the unforgiving environment of space. Nevertheless, NASA's resilience and determination in continuing its Mars exploration efforts remain steadfast, and the lessons learned from MAVEN's mission will continue to guide future endeavors to explore the Red Planet.